Here are the top robotic skills everyone should learn in 2023. In this video, I have made a comprehensive evaluation of the different skills and categories of skills that everyone should know in robotics. And these could include mathematics skills, these could include software tools and frameworks, these could include ROS, these could include the programming languages that you should know if you want to become a robotics software engineer. And these could include soft skills and other meta skills that one needs to know if you want to work as a robotics software engineer professionally. So let's start. So first I'll be talking about the learning framework. By the learning framework, I mean the methodology or the overall system that you can adopt to start learning robotics if you want to become a self-taught robotics software engineer, computer vision, or even machine learning engineer. So it's the kind of idea on which you could plan your own robotics curriculum or your own robotics program or structure for yourself. And then I'll be talking about overview of different categories of skills that one needs to know for robotics. And then I'll be breaking down in detail all of the several categories of skills, all the several individual skills that one would need to know. So this is going to be the most comprehensive evaluation of all the skills that one needs to learn in robotics. And no such video like this exists on YouTube or online where a comprehensive evaluation of different skill sets is made. Especially for robotics, people talk about in general which programming languages one should use, which tools to use, which kinds of thinking approaches one should adopt, and so on. And in this video, I have attempted to create a comprehensive list of different categories of skills. So I hope this would be useful. And then I have also talked about how you can choose the right skill set based on your own personal goals. And this is especially important because on this channel, I target people who want to become self-taught robotics engineers, computer vision engineers, or machine learning engineers, basically software engineers in the AI domain. And if you want to become a professional and if you want to work in a company or in the industry after acquiring your skills, you have to understand which skills to focus on, because of course Python is important, of course C++ is important, maybe MATLAB is important as well, but which languages are most important, which tools are most important? And this is what I'll be trying to cover in this particular section. And then how you can go about acquiring this skill set. So a specific approach would be given to you, which you can adopt to start building this skill set on your own, leveraging the internet resources and anything that you find online, and build a system for yourself. So let's get started. So again, this video is targeted towards people who want to become self-taught robotics software engineers, computer vision, or machine learning engineers. And the framework that I encourage you to adopt if you want to start learning as an absolute beginner is something that takes into account your curiosity, something that takes into account the fact that you want to explore several different subdomains in artificial intelligence and robotics, and eventually find a niche for yourself, and then try to gain mastery or expertise in that specific niche, and to the level that you actually become employable in the real world. So this is what I'll be focusing on. So this little T that you see here is a typical framework that is generally used in not just robotics but in a lot of different fields, where people talk about you should have a broad set of skill set in several different subdomains of a particular bigger category, and then also an expertise. And this is expertise is highly valuable because this sets you apart from other people, and the industry knows which role you're targeting essentially. And for robotics this is particularly important because you need to have an interdisciplinary understanding of the overall robotic system, which consists not just of sensors and mechanical systems but also electronics, and of course artificial intelligence algorithms and web development frameworks that might be used to display, for example, an interface for a particular product and so on. So all of these things are essential to learn. Now, what should you do as a beginner? I've covered this in more detail in my video where I talk about the overall comprehensive roadmap that you can adopt to start learning robotics, computer vision, and machine learning in 2023. So, this is just going to be a quick introduction, and you can watch more details about how you can structure the entire year, create a plan for yourself, and use this framework essentially. So let's quickly cover this particular approach here. So in this particular approach, I mentioned that you should start with curiosity. You should take into account what your personal interests are and try to approach projects in that way. And when you do that, you'll be able to, of course, get a broad level of understanding. And this broad understanding also comes by deliberate seeking of different subdomains in robotics and AI. Then you find niche, and then you try to gain an expertise in a particular niche. And the framework that I talk about is basically three-step framework that starts with a curiosity-driven exploration approach, a domain-driven exploration, which allows you to explore several different domains, and then a progressive mastery framework, which allows you to master one specific niche. So in this video, I'm not going into too much detail on what these terms are. I've explained all of these in a really long 1.5 hour video, which allows you to build a roadmap for yourself for the entire 2023 year. Um, and you should watch that if you struggle with planning and organizing your learnings and just don't know where to start. So let's talk about overview of skills that are needed to become a professional robotic software engineer. So one of the most overlooked skills in robotics is that of teamwork and understanding interdisciplinary participation, lateral thinking, creative ideation, of course, problem solving skills, and things of this category. And all of these things I have labeled as meta skills, and I'll talk about this particular category of skills, which is equally as important as technical skills and programming skills. And I encourage you to also focus a little bit on this aspect, and I'll cover what are the skills you should focus on in the coming slides. The next category is general software engineering tools. So we talk about learning programming languages, we talk about learning the theoretical foundations, kinematics and dynamics, and all these kinds of things. But what is probably missed is the fact that you also need to learn certain software tools that are being used in the industry. And if you know that, you would have an advantage over other candidates, because sometimes you have to join a company and then you have to learn those tools anyway. But if you know the tools already, you'd be given preference over other candidates. So this is particularly important, and also allows you to become a better team player and use the tools to collaborate with other members of of the team essentially. And then I'll be talking about which programming languages to use, what specific programming skills you need to cultivate, and anything related to programming basically. And then I'll be talking about robotics specific tools that you should know if you want to become a robotics software engineer. And these could, of course, include an alternative set of tools, but I'll be talking about the ones that are used most commonly in the industry, and the ones that would help you easily adapt to other tools if you know those. So I'll be talking about that. And of course, mathematics tools. Mathematics is at the foundation of anything we do in engineering. And if you, regardless of whether you are a mechanical engineer, electronics, computer science engineer, or any other engineering domain, you know that mathematics is essentially very important. So this is something we would be laying a special emphasis on, and I'll be covering specific topics in mathematics that you should be focusing on. So stay tuned for that. Let's come to meta skills first. So the first meta skill that is extremely important, and this is not just for robotics but any field in general, is that of curiosity. And that is extremely important because if you're curious about a particular topic, of course you're going to be intrinsically motivated to study further and learn more and more on your own. And as a self-taught engineer, as someone who wants to work professionally by acquiring knowledge on their own, this is extremely important because it will keep you engaged for a long time in your learning journey. And in robotics and AI, there's a lot of developments that are going on at a very quick pace. So if you lack curiosity, you're probably not going to enjoy the process very well, because sometimes it can be a bit hard to understand some difficult concepts. So make sure you exercise your curiosity by asking questions, by checking out what the latest developments are, and just staying updated with the state of the art. Another thing that is probably overlooked a lot is that of lateral thinking. Now, what is lateral thinking? By lateral thinking, I mean the ability to think across in a way that you are able to generate specific ideas for one particular problem. So specific different ideas for one particular problem. And if you're working in an engineering team, and if you're involved in the initial design phase of any particular problem, you probably need to come up with lots of different ideas, lots of different solutions to a particular problem, and try those things out. This is also extremely important in research, because you have to try out a lot of different things, fail many times, and if you're unable to come up with new ideas, this can be a challenge. And this is a skill, which means it can be cultivated over time by practicing it, by deliberately engaging in lateral thinking activities. The best way to do that is to take a problem and to generate lots of ideas. That is how you exercise your lateral thinking ability. Teamwork, as I mentioned, robotics is extremely interdisciplinary, and essentially wherever you work, you would require to have the skills to collaborate in a team, to be able to understand the different complexities of the problem from different perspectives, to communicate well. Communication is another meta skill. And these are just general skills that one needs to know. These might not be related to robotics, but specifically lateral thinking and teamwork are more required in robotics and AI or any interdisciplinary product company, let's say. Problem solving, pretty self-explanatory. Active learning. Active learning is essentially very important because you need to be actively involved in learning activities that allow you to develop your skills in robotics and AI. Because the fact is that new updates are coming up in all of these subdomains, and you need to stay updated. You need to upgrade your own skills continuously, even after you have graduated from a university and are working in a full-time position. You still need to be actively learning, actively acquiring new knowledge, and this is essentially very, very important. The other thing is persistence. For software, as a beginner, you would probably struggle a bit debugging certain problems, finding the right packages, even trivial things like installation of packages and solving dependency issues. These are things you have to be a bit persistent in. So this is very important as well. You should be also developing your systems thinking ability. By systems thinking, the idea is that you think of robotics, the overall robotic system, whether it's a humanoid robot, mobile robot, or agricultural robot, or any other category of robot. You think of the overall robotic as a beautiful piece of complicated system where all of the different components, the gears, the programming frameworks and everything work together in harmony such that the overall robotic system, the overall robot, mobile robot, drone, whatever, is able to perform the task that we require of it. So this is also particularly important for robotics. The way you develop curiosity, as I mentioned, is by practicing asking questions. Lateral thinking, the best way to practice is to take up a problem, brainstorm several different solutions to the problem. The way you can practice teamwork is by taking up projects and then doing the projects in, let's say, a group of people or accountability partners. And that way, you're able to simulate the way you might be working when you work for an industry or for a research institute. Communication is by presenting your ideas. So you learn certain concepts, you express your, you share your project ideas with others, you just talk to different kinds of people and you share your ideas, and that way you'd be able to improve your communication skills. And essentially this is something that you can also learn uh, while documenting your projects, which is probably what you would be doing if you want to showcase your projects to a potential company after you acquire certain skill set. Problem solving skills is by taking up projects. Active learning skills is by learning new concepts and staying up to date. Persistence is something that you can develop by just sticking with the problem, whether you encounter it while debugging or any other hardware related issue that you might overcome. Systems thinking is something that you can develop by taking part in interdisciplinary projects, and any robotics project in general would allow you to exercise your system thinking ability. So, how do you develop your mathematics skills? And more importantly, what are the mathematics skills that you should focus on in order to become a robotics software engineer? Calculus, statistics, geometry, group theory, linear algebra, probability, numerical analysis, and control theory. So, nothing to explain in too much of detail here. These are several concepts for which you can solve problems online. You can purchase a mathematics book and try to solve problems and just develop a certain level of foundation so that you are able to solve problems in robotics when you're actually doing projects. So calculus, where is calculus used in robotics? So calculus is used in a lot of different areas in robotics, in particular for robot motion and control. Where is statistics used? It is definitely used a lot in machine learning, and it is used also for sensor data analysis and a few other domains as well. So statistics is very important, and particularly important if you want to also develop your machine learning skills, so as to become a robotics engineer in the machine learning domain, or a machine learning engineer independent separately as well. So that was extremely important. Geometry is important for computer vision, for robotic manipulation, and basic geometry is just something that is fundamentally very important if you are an engineer, and you probably know that stuff. Group theory is something that is not popularly talked about, but it is used in robotics. It is used for several algorithms for robotics, and used for symmetry analysis. And you could also find a lot of information online on Lie groups and group theory, and you could develop a foundation on that. Although if you even know the other skills that I talk about and don't spend too much time on group theory, you'd still be able to do quite a few projects. So that is an optional additional thing to focus uh, on top of the other skills. Linear algebra, robotics, kinematics, and dynamics. Linear algebra is basically very fundamental mathematical tool, if we may call that, and that is something you should also know. Probability, also for sensor data analysis and machine learning. Then we talk about numerical analysis, and that is something you use for precision tasks when you're designing algorithms for precision tasks involving robotic manipulation, or movement of the robots in certain ways. Control theory is for robotic motion planning and control. So hopefully this gives you a brief overview of the different mathematical skills that are required, and this pretty much is very comprehensive. And if you know all of these skills or even most of these skills, I think you should be comfortable taking up a robotics project, and you know how to set your foundation in each of these mathematics skills. And if you want specific resources, just maybe comment on this video, or write a message to me, and I'll think if I can provide some specific resources to develop mathematical concepts specifically for robotics problems. Now let's come to general software engineering tools. So Git, this is something that I talk about extensively. I tell that one should always learn Git before you even start learning robotics software, computer vision, or machine learning, or any subdomain of AI basically. And I also encourage you to start learning Ubuntu and becoming more familiar with that operating system, and slowly giving up on Windows and just focusing entirely on Ubuntu, because this is being used everywhere for robotics problems, for machine learning, computer vision, NLP, all the AI domains, all the software engineers essentially prefer that for its simplicity and faster processing, and it offers a lot of other advantages that you could look it up. But essentially, you should try to spend some time learning Ubuntu. You should learn Scrum and Jira. These are tools and frameworks that are used for software development, especially important because you'll be working in a team in a company, and you should be familiar with the concept of agile development, the agile framework of software development that allows quicker software engineering pipelines, and how to make sure the entire software team is working efficiently and all the tasks are getting done and so on. So this is something that is very, very important to know, and companies explicitly ask for these skills in the job descriptions as well. So please focus on this. Another one would be some familiarity with cloud storage services like Amazon Web Services or Azure, and you could find several courses, few videos on YouTube, and a lot of different resources. So this is something you could focus on. Although I would say it is not, if you don't know that, it's not that big of a deal. You could easily learn this up in a company as well. So I'd encourage you to spend an hour or two at least getting familiar with it. Docker containers is also something that you would need to know as a robotic software engineer. And shell scripting is something that you would need to be familiar with, because if you're using Ubuntu, you need to be writing scripts, you need to be writing commands on the command line, you need to be probably also writing bash scripts and so on. So just Google it, just try to understand what this is, just gain a basic foundational understanding of this. Unit testing, again, a more software engineering related thing, and this also something that you should be focusing on. Another is continuous integration and continuous deployment. Just look up CI/CD pipelines. In this particular section, I aim to just give you a list of the different skills and where they are probably used in the robotics, or could be used in the industry. And these are skills that you have to spend time creating a plan for yourself, such that you learn these things, and these would give you an advantage over other candidates. And Git is a version control system, and there are essentially other version control systems that you could learn. There are some companies that don't use Git, but they use other similar tools, and that is why if you know Git, you'd be able to easily learn any other version control system as well. The whole idea is you should understand why this is important, and gain a foundational understanding of the basic tools. Just get familiar with using it. And you can also watch my video where I talk in detail about what Git is. We talk about different version control systems and so on, and some basic commands for Git that you can use to start learning. Just look up Git on my YouTube channel, or essentially any other YouTube channel, to gain a foundational understanding. You need to know about Ubuntu, you need to know about agile development, as I talked about, cloud computing. Docker is also for cloud and robotic deployment, essentially, that you should be knowing about. And then shell scripting, if you are in robotics, you'd be maybe making a sequence of tasks and so on, and then you'd want to automate the tasks to make your overall working pipeline easier. So this is something that you should be focusing on. Unit testing is for reliable development, and so that the the overall pipeline works as expected and you're able to test the software that is being created. Essentially, CI/CD already mentioned. Let's talk about the most important portion of this video, which is programming skills. C++, MATLAB, design patterns, debugging skills, Python, software architecture, object oriented programming, front end framework. Now, some of these skills that I mentioned are here are some programming languages. Some of these are general software engineering related things, some general programming specific things like object oriented programming, learning about software architectures, design patterns, and so on. So, here I've tried to cover the things that are important for a robotic software engineer. So, coming to the question of whether you should be learning Python or C++ for robotics. Now, this is probably a very popular question that people ask about, and as a beginner, if you're an absolute beginner, I would say that you start with Python for the simple reason that it is simpler and you'd get used to it very quickly. And for machine learning, and even for several machine learning related computer vision projects, Python is more widely used. Even for other computer vision applications, or the applications which require you to deal with cameras or robotic systems, C++ is more widely used. But even then, I would encourage you to first learn Python if you have no programming experience, to get familiar with it, and then spend more time learning C++. So take it as a progression that you could follow for your own learning system. And eventually, you need to understand that for machine learning, Python, machine learning and data science, Python is more important, and for interaction with the hardware and for low level control stuff, C++ is more important. So low level planning and control, as I mentioned, C++ is of more importance. For testing, simulation, and prototyping, MATLAB is also used. So this is something that you can also focus on. Although if you know Python, you should be able to get started with doing projects that build your portfolio, essentially. So you need not know C++ or MATLAB as an absolute beginner. If you know Python, I'd encourage you to just start taking up projects and building your portfolio. And eventually, if you take up more hardware related projects or the ones that deal with camera, maybe you could start learning a bit of C++ and also MATLAB. Now, design patterns, debugging, and software architecture is something that you need to learn as a software developer. So these are more software related skills, more programming related skills that you need to develop. And again, take up a course on Udemy or Coursera or wherever you find a good course on design patterns and a systematic way to debugging. Although I think debugging is something you can only learn by taking up projects and then getting stuck and then trying to understand the code better in a way that you'd be able to then efficiently debug and solve problems. Learn about software architecture, learn about object oriented programming, what it means, how it makes the code more modular, and so on. Learn about front end framework. This is optional, you don't need to know that. But if you know about the graphical user interface and you're able to showcase the results of computer vision, machine learning, or other projects, and are able to make a framework very quickly, you have a significant advantage. Although this is not a mandatory, you could become a really good robotic software engineer or computer vision or machine learning engineer, even without knowing front end development or learning about building a front end interface essentially. So, talking about robotics tools, and the number one robotics tool that you would need to know is ROS, and you know about this. You've heard everyone talk about it, and this is extremely important because every industry uses ROS or something similar to it. So there are equivalents and lesser known frameworks. There are frameworks that companies might have developed only for their own specific company or for some specific projects in those companies, and you might need to learn those as you join the company. But if you know ROS, if you have experience with ROS, you're able to transfer that knowledge towards that framework, because that framework would be more or less similar in NumPy, SciPy, and Pandas. If you want to learn machine learning, NumPy, SciPy, Pandas, these are some basic data science, data related packages, and just general packages that would be helpful to you if you're using Python. So these are packages you can consider. You can learn a simulation tool like Gazebo, although PyBullet and Isaac, and there are several different simulation tools that you could be using. But if you just focus on learning one, as I said, you can master other tools, other simulation tools also very easily. PyTorch or TensorFlow, again, if you want to go into machine learning, you have to know either PyTorch or TensorFlow. These are the most popular frameworks that are used today. And you just choose one, start with TensorFlow. TensorFlow might be slightly easier to start, and then you could switch to PyTorch later if you want to, or you could just stick with one of these frameworks and try to do projects using that framework. ROS is a more robotic specific framework. NumPy, SciPy, and Pandas are data science tools. Gazebo or any other simulation tool is something you need to know as well. And for machine learning, PyTorch or TensorFlow, to summarize all of the different robotics tools. And basically, that's it. You don't need to know a lot of different tools. And that is why I emphasize on the fact that you should be focusing on projects and start building projects to gain some pseudo real world experience, some pseudo practical work experience that would be beneficial to you, and you would gain a lot of confidence once you build projects, upload those projects on GitHub, and start sharing with others and get feedback on your project. So that is the most important thing. Now, these are a lot of skills, and it can still get a little too confusing for you which programming language to focus on. Although I mentioned that as a beginner, just stick with Python and try to learn it and try to do projects with it. And for hardware related things, you could still start with Python, but eventually you would have to switch to C++ and so on. But what are the specific tools that you would need to learn for your own specific scenario, for your specific goals, for the specific location that you are in, for your specific work environment, for your specific subdomain or niche that you want to gain an expertise in and you want to work in the industry for? So these are job oriented skills that you would be focusing on. You should be focusing on skills that the companies are using, and this is the key point. You don't want to learn a framework from 20 years ago that nobody is using anymore. No, none of the companies, none of the research institutes are using it, and you still just randomly start learning it because somehow there's a certain level of popularity with it, or you just find that easier to use. So that is not a good idea. You should be focusing on skills that would make you employable in the real world, learning for employability, and develop projects, take up projects that allow you to gain those skills. And in that sense, you'd be able to get a simulated work experience, and you'd be equally as good as other candidates who are probably enrolled in a typical master's program and so on. You can learn the tools that are being used in the industry. So in all of these points, I just lay emphasis on the fact that you should be specifically focusing on the few skills, the few tools, and develop a portfolio of skills that are being used in the industry and that the industries value. Now, here is a small activity that you can do for yourself to identify those skills. Now, this activity is part of the whole overall framework, the whole overall roadmap that I talked about in my 1.5 hour video called the most comprehensive roadmap to start learning robotics and AI in 2023. Make sure to check that out. And this particular activity is probably not there because this is something I plan to include in a specific course where I am more flexible with the overall structure, and I can provide things in a more step by step way, which is not possible on YouTube, where I create videos which are not interconnected in any way, and there's no sequential and practical activity driven system that I can develop here. So this is something I want to offer as part of a course, which is still something that I need to develop, but this is something that I plan to release by the end of the year. And this is just to give you a short glimpse into what the course would look like, the different modules that would be there, the different kinds of activities that would be there. You'd get a better overall picture by watching the 1.5 hour video on the most comprehensive roadmap to start learning robotics and AI in 2023. So if you're looking for a system to learn, I think this video is getting a good response so far, and I'm 100% sure that this would be beneficial to you. So check that out. Coming to this activity on how you can find a skill set, this is a very short practical activity that you can do. First, you start with identifying the fields that you would be interested in. So here I've written that identify the fields encompassing the 3 chosen projects. This is part of the overall system where you'd be doing several other activities previously to filter out some projects, decide on some projects that you would be doing and so on. But for this particular case, you have to find the fields that you're interested in first. So let's say you know that you want to go into mobile robotics. Let's just keep it simple and let's just talk about the case where you want to learn mobile robots and want to become a robotics software engineer in the mobile robotics domain. Then you'd start Googling as step two and find a list of 5 companies that are working on the area that you're interested in, that are building projects that you would want to build. And you would do that before you have built any project, so that you focus on the right sort of projects that you would build for yourself. And to point out again, the best way to acquire skill sets is by taking up projects. What are the projects you should be taking on based on your interests, and also the ones that are being developed in the industry, the ones that are actually that the companies are actually working on. This is part of the overall framework, and this is something you can again check out in that particular video. And here in this particular case, you make a list of 5 companies in your location, like wherever you are. Take those constraints into account and take your interests into account, take the field, take the kind of projects that are they're doing into account. Make a list of these 5 companies. Simple as very simple. Go look for job openings on the websites of those companies, and then identify the tools and skill sets that they have mentioned. And you'd notice that a lot of companies would have mentioned ROS. A lot of companies would have mentioned whether they want Python or C++. And if you see that out of these 5 companies, let's say 4 companies have mentioned that they want a C++ engineer specifically, and only one of them have written that they want a Python developer, then you know that you should be focusing on developing your C++ skills. This will give you immense clarity, because are now absolutely sure that you would be, if you work on these skills, there are jobs there that would make you employable. So look for job openings, identify the tools and skill sets, and then do the projects that use these tools. And this is the critical part. You chose mobile robots as the field, you define a certain number of projects that you would want to do, some basic mobile robots projects. Maybe you do it in simulation, maybe you use Gazebo and Ross, and you use the turtle bot as a simple project. Maybe then you take up the Husky robot, or one of the drones, and take up more complicated projects. But you make a list of projects that use these skills, and you start building that skill set by building these projects. So this is very important, very fundamental, but I feel like this point needs to be emphasized here. So acquiring the skill set is taking up projects. I mentioned it so far. Another way to acquire skills is by taking up Udemy courses, which are very cheap. You can watch YouTube tutorials and videos and try to develop those skills like that, or you could just take up a project from your own interest that allows you to learn, let's say, Git, and you could Google search along the way. So, as I mentioned, the most comprehensive roadmap to learn robotics and AI in 2023 is in the long video. And if you're interested in being on the waiting list of the course that I plan to create by the end of 2023, called How to Become a Self-Taught Robotics Software Engineer or Computer Vision or Machine Learning Engineer, then make sure to go to learnroboticsandai.com, and you'd click on start here, and you'd be redirected to a page that talks about the course and what my initial ideas for that course are, what are the modules that I plan to cover, and things like that. So if you're interested in that, you can check that out. And to give a short overview, um, the roadmap that I talk about in both in the video and that I'll be using in the overall course is that the first step would be about cultivating the mindset. Second would be about setting the foundation, learning the mathematics tools, the frameworks, ROS, and things like that. Focusing on projects based on your own curiosity, then focusing on projects that allow you to gain expertise in several not expertise, just gain some rudimentary understanding of several different domains. Then you choose a particular um domain, then you choose your particular niche, you find your niche, and then you build the project. And I'll be talking specifically about how to structure your projects, how to approach a project from a problem solving perspective, and a lot of different things in the course that I plan to cover. And I'll be talking about how you can gain mastery over, let's say, one specific niche that you choose, for example, machine learning for a specific application. I'll be also talking about the practical aspects which the other robotics courses don't talk about, which is building a portfolio and actually showcasing your projects, applying for jobs, and continuing your learning even after you have a job and you're employable. And this is the course. Again, check out learnroboticsandai.com and click on start here, and you'd be able to get more details on it. And basically that's it. I hope this video was helpful to you, and if it was, make sure to leave some comments. Just share your ideas. It doesn't have to be positive comments. You could share your constructive criticism or any feedback on what modules to include in the course and whether or not this video is helpful. So I think this feedback really helps me create better content and help you in becoming a self-taught robotics software or computer vision or machine learning engineer.